All right, another help request for exercise 8.3. So our isothermal CSTR with a series and parallel reaction going on. Okay, so let's take a look at the code that was received. Okay, so I'm going to take this. Well, I might need to move my head again. Let's make this full screen. Okay, and see what we have. Okay. So type must be choosing if it's a series or parallel. We'll have to take a look at the multiple, the plot title, and the plot name. Okay, cool. Initial concentrations of A, B, and C. Gas constant and temperature. Our activation energy, which you're converting to joules per mole. Pre-exponential term, good. Then you compute my rate constant, good. All right, and since the temperature is constant, we can do that. Vector of tau values. Then vectors to collector concentrations of A, B, and C. Okay, good. Okay, so if it's type 1, okay, so type 1 must be parallel. Okay, so let me just say it must be parallel because you have A as a reactant in both, B a product in the first, and C a product in my second. Activation energy for reaction 2. Then K naught 2 is a multiple of K naught 1, and then you compute the rate constant for that case. Now, just a comment as I try and keep track of all this. So there's an if block nested within your function. It should probably be indented, right? And then this for loop should be indented relative to the if statement, just so we can keep track of all of these things. But a loop over tau. Okay, let me copy this and let's look at that concentration error function. So we're going to create an anonymous function where the only input CV, so that must be concentration of A, B, and C, which we're going to solve for. And so I'm looking for concentration 1. Concentration 1. Okay, so this is a long list, so I'm just pasting this to try and match up. So there's CV, that's stoichiometric coefficients of my components. Okay, my tau value of interest, my initial concentrations at K1 and K2. Okay, that looks good. So within here, unpack CV, so you get concentration of A, B, and C. Rate expression, good. All right, and your rate expression has to appear in here because it's dependent on CA, which we're trying to solve for. So you convert the space-time from minutes to seconds. Okay, so tau in your for loop then is in minutes, so that would have been a good thing to indicate up here. Well, I guess you do, it's in minutes. Okay, so you convert from minutes to seconds because your unit of time in your rate expression is inverse seconds. Mole balance, CA minus CA naught, minus tau times stoichiometric coefficient reaction 1 times R1. Looks good. Looks good. You pack it up. Okay, so that looks good. I see no issue with that. Okay, now I just need to keep track of where we are. Okay, so I see no issue with that. Then you solve and pack up the results. Looks good. Not sure if 1, 1, 1 will work, but let's leave it. So then if it's type 2, presumably this is exactly the same. And so I won't bother looking at that with the fine-tooth comb. All right, so I think this is kind of the issue you asked about. Compute the selectivity. Selectivity of V relative to C. So actually this was a typo in that original reading, right? I had NB over divided by NC is equal to, should have been CB over CC, right? So this should be, and actually it's not, you don't use C, you use big A and big B. So selectivity should be B, and since B is a vector, it should be P period divided by C, okay? But now this isn't exactly going to work. And why it isn't exactly going to work is at tau of 0, then you're going to have 0 over 0, which is going to be problematic, right? And so we'll look at that, say, when we plot it, okay? So the first entry I know is going to be problematic. It's going to be 0 over 0. Then you compute the fractional conversion. Okay, so again, I don't know where your CAs are coming from. So you have CA naught. So you have CA naught, but then this should be A. A is your vector that contains your concentration of A's. Okay, and so then, you properly use them there. So plot. Okay, this, you're almost definitely going to want to put on a different figure, right? And then you're almost definitely going to want a separate figure for FA. Okay, so what I might do is, let's see, do you have any clear figures or anything up top? Okay, so you have a clear figure, then figure 1. Okay, so I would say, put all that on figure 1. Okay, hang on, let's get this. I'm just trying to keep track. So I don't want to completely delete it because I want to copy and paste fractional conversion and selectivity. Okay. All right, so then what I would try and do, all right, if you were to, create these figures, is you could create like a figure 2, and figure 2 could be, say, just selectivity. And so if I plot selectivity then, so now figure 2 is activated, and I could plot tau versus selectivity, we call that SBC. And plot that as, say, a black line. Okay, and then what you're going to have to play with is just the y limit, because again, at time equals 0, it's going to be 0 over 0 infinity, and even at really small times, it's going to be ginormous. Okay, so we'll plot it, and I'll leave that to you to play with. All right, but at least we'll make sure this is all working. Okay, so let me plot tau versus FA in figure 3. Let's just save that. And so in FA, again, we just converted, you had CA before, changed that to A. Bam. So then you had an example of how to call this. Okay, figure 1 has nothing in it. It says undefined function of variable CA naught. Okay, so let's maximize your code again, and that's in line 97. So you have CA underscore O. So C, so I copied it. So this should be CA underline O. Okay, so figure 1 looks good. Okay. Figure 2 was selectivity. Okay. So actually time equals 0 in this case looks okay. So you'll see, some choppiness, some noise here, but that's actually perfectly okay. So if you look at your y-axis, so the ratio of your pre-exponential term should be 10, right? So this is equivalent to that ratio. So So your rate of reaction 1 in which B is being produced is 10 times faster than your rate of reaction in reaction 2. So this should be a constant value of 10. Where you see this fluctuation is just numerical noise. But again, look at the scale of your y-axis, right? Essentially, it is constant within the precision of MATLAB. And then this looks good for your fractional conversion. Okay, so looks like all I had to do is fix a couple typos. Okay, I would leave it up to you to tidy up your graphs. Okay, make them look a little prettier. And if you wanted to return tau and your concentrations, by all means, you could do that. Okay, let's just look at type 2, which would be our series case, and see what we have going on there. Okay, so now we're not plotting. So let's see what we have. For CV. All right, so let's take a look at that objective function. So that's fine. Okay, so what we want to look at is here. So I'm looking at concentration 2 now. So one thing that stands out to me is that the rate expressions jump out to me. That should be CB there, but let's check this out. CV, stoichiometric coefficient, specific tau, CA naught, CB naught, CC naught, K1 and K2, that's fine. I unpack. Okay, rate 2 should be first order in B. All right, for series. Okay, so you have that fixed. And then that's exactly the same, so it should be right. Oh, for some reason you have cons here, right? It's CV, right? You had it right up here for parallel, right? So CV, or you change that to cons, one or the other. So let's minimize this. All right, so this is actually series. I guess it should have changed the name. Okay, but yeah, it looks beautiful. Okay, figure 1 looks good. Concentrations. Figure 3, my fractional conversion looks good. And selectivity actually looks good too, right? I thought that you should start out with essentially 0 over 0, that this should be even bigger. But apparently not, right? All looks good, okay? All looks good. So hopefully that can get you set up and get you going. So what we had to change for parallel, biggest issue was in your objective function, you weren't using consistent notation here for your vector of concentrations that you're trying to solve for. And then down in your error function, and notice that R2, right, it's going to be first order in B, not A. All right, but otherwise, that looks good. All right, hopefully that gets you started and going.